We're going to demonstrate two-dimensional velocity by using this here red car and this here blue car. See, what we are going to do is, we're going to take the treadmill, right here, treadmill. Put the little car right here. The treadmill is going east. The car is going north. The average time of the blue car to go 100 centimeters is 4.76 seconds. And the average time for the red car is 2.28 seconds to go 100 centimeters. To find the velocity speed, you take the distance over time. So in this case, I'm going to do the red car, 2.8 seconds. It will be 44.44 centimeters per second. So I'm going to go over here and do the same thing for the blue car. Meters over 24.76 seconds equals 21.01 centimeters per second.
Okay, today we'll be talking about two-dimensional velocity based off of the blue car. The blue car is traveling from south headed north. The treadmill is heading west to east. The treadmill is going at a rate of 22.35 centimeters a second. This is also known as half mile per hour. The car is traveling north across the treadmill at a rate of 21.01 centimeters a second. As the blue car travels across the treadmill and the treadmill pushes against the car, it is going to cause it to move in a diagonal direction. We want to find out the time that it takes for the blue car to travel across the treadmill onto the other side.
Yep.
Okay, in order to find the time that it takes for the blue car to travel across the treadmill, we're going to have to take the blue car's velocity, which is 21.01 centimeters a second. We're going to have to set that equal to the displacement over our variable, which would be t. Once we find that, we need to factor it out. Divided by 21.01. And that'll give us the time, which is 2.38. Alright. Now that we found the time, we're going to use that time to find the displacement from here to here. In order to do that, we need to use the velocity of the treadmill, which is 22.38, or 35, excuse me. And we're going to use the time that we just found, that was 2.38. We're going to set that over delta x, this is what we're trying to find. And once we multiply those out, that's going to give us a displacement of 53.193 centimeters. Explain this in a more simple manner to where you can see all of the information in one chart. We're going to place these in X and Y column. The 53.193 would be our delta X. This is in centimeters. Our delta Y equals the 50 centimeters, which would be the width of the treadmill. Our velocity of X would equal the 22.35 centimeters a second, also known as the speed of the treadmill. Our velocity of Y would equal the speed of the blue car, which is the 21.01 centimeters a second. So there we see all of the information that we used and the information that we found to also give us time, which would equal out to 2.38 seconds.
Alright, so today we're going to find the velocity, the delta x of a car going across a treadmill. So we have our delta y, which is 50 centimeters, is the width of the treadmill. We have our velocity of y, which is the car going across the treadmill, 44.44 centimeters over seconds. And our our velocity of x, which is 44.70 centimeters a second going east. And our velocity of y was going north. So, I'm going to plug this all into this chart down here so it's a little more organized. We got a question mark for our delta x, which is our variable. Okay, so first we got to find the time that it took to get across the treadmill, and then we can use that to find our delta x. So, to find time, we use our velocity, 44.44 centimeters per second, set it equal to our delta y, 50 centimeters over seconds. Multiply by seconds, get it off the bottom, and then divide by 44.44 centimeters a second. 0.44 centimeters per second. And then that obviously cancels out, So seconds equals 50 divided by 44.44, which equals 1.125 seconds. So we got our seconds. This is how long it took to get across the treadmill. That's our time, so we're going to put this down here. So now we're going to plug in our time to find our delta x by putting our velocity of x, which is 44.70 centimeters per second, equal to our time, our delta x over our time, which is 1.125 seconds. Multiply by this to get off the bottom. Then you get 50.2875 centimeters, because the seconds canceled. And that equals our delta x. To be organized, plug it in down here. 50.2875. So we found our delta x by using our delta y, velocity of y, and velocity of x. It's just a 2D velocity.
.01. We're going to have to set that equal to the displacement that it travels, which would be 50 centimeters,